This is the 2019 impacts and collisions question. Question 5 always. Smooth sphere A of mass 3m moving with speed u collides directly with a small smooth sphere B of mass m moving with speed u in the opposite direction, so minus u. That's what's going on before. Afterwards we will call P and Q. So principle of conservation of momentum, 3m times u plus m times minus u is equal to 3mp plus mq. So you're going to get 3mu minus mu, and dividing across by m, we're going to get 2u equals 3p plus q. Newton's experimental law, p minus q, v1 minus 2, v2 over u1 minus u2, which is u minus minus u, is equal to minus e, which we're told is a half. So minus a half. 2p minus 2q equals minus 2u. Dividing by 2, p minus q is equal to minus u. Bringing the first equation down, 3p plus q is equal to 2u. So we're going to get 4p is equal to u. So p is equal to u over 4, or a quarter of u. We have q here from this line. We could say that q is equal to p plus u. So that's a quarter u plus a full one, which is 5 quarters, or 5u over 4. So we have p and we have q. Now what do we ask for? Find the value of u. So after the collision, B hits a smooth vertical wall which is perpendicular to the direction of motion. The coefficient between B and the wall is 2/5. So its new speed after it hits the wall, 5u over 4 multiplied by minus e. So what do we say it was? 2/5. 2/5. It's going to be going back in the direction. 2u over 4, which is equal to u over 2. So that's the speed it's going to be going back at. We could say it's minus. I don't think we need it in this case. So the first collision between the spheres occurred at a distance 2 meters from the wall, and they collide again 4 seconds after the first collision. So here's the collision. Here's the wall. This guy here, Q, is traveling in this direction towards the wall with a speed of 5u over 4. And the distance is 2 meters. The distance is equal to 2 meters. So we can get the time then using our DST triangle. Time is equal to distance over speed. So 2 over 5u over 4, which is going to be 8 over 5u. So we need to know how far has P traveled. P is here. How far has P traveled in this time towards the wall? So we need distance, and distance is equal to speed times time. So for P, the distance traveled is going to be equal to its speed, which is u over 4. And the time is 8 over 5u. The u's will cancel. 8 over 20, which is 4 over 10, which is 40 centimeters. So let's say P is now here, 0.4, he's at now 1.6 from the wall. So we have two spheres 1.6 apart. One is going that way, one is going that way. P is here traveling with a speed of u over 4. Q is here traveling in the opposite direction with a speed of, it's a new speed, what did we say it was? U over 2, after the coefficient of restitution is taken into account. U over 2, and they have to travel a distance of 1.6. So we can say that u over 4 times t plus u over 2 times t is equal to this 1.6. Multiplying by 4, I get ut plus 2ut is equal to 6.4. Sorry, ut. So 3ut is equal to 6.4. So the time taken, well, it hit the wall. This is how long it took to hit the wall. The next collision occurs 4 seconds later. So what's left? 4 minus 8 over 5u is the time left. That's t. So 3u times the time left, which is 4 minus 8 over 5u, is equal to 6.4. So we're going to get 12u minus 24u over 5u minus 24u over 5u, just minus 24 over 5. So 12u is equal to 6.4 plus, what's that, 4.8? So 12u, does this work out evenly? 12u is equal to 11.2, no it doesn't. U is equal to 11.2 over 12. And if you type this into a calculator, you get 0.93 recurring. So 0.93 meters per second is the answer to this question.